There is no law that requires a printer to last. No regulation that defines how many pages it should print before it fails. No standard that forces manufacturers to design for durability instead of replacement. What exists instead is a set of constraints, cost targets, warranty limits, competitive pressure. And within those constraints, manufacturers are free to make a series of decisions. Each one individually reasonable, each one technically defensible. And when those decisions accumulate, they shape a product that behaves in a very specific way. It works until it doesn't. And when it stops, replacement often makes more sense than repair. You don't think about your printer when you buy it. You compare prices. You check reviews. You assume it will work. And for a while it does. Then one day, something changes. The print quality fades. The colors misalign. The device refuses to recognize a cartridge that was working yesterday. A message appears. Maintenance required. Parts inside your printer have reached the end of their service life. Contact support. And suddenly, a device that looks perfectly intact stops functioning. Transition. This isn't a rare defect. It's a pattern. And to understand that pattern, you have to look beyond the printer itself, into the system that built it. Printers are not sold the way they appear. At first glance, a printer looks like a product, a physical device, a one-time purchase. But economically, it functions more like a platform. The initial price is often low, sometimes surprisingly low. In some cases, lower than the cost of manufacturing the device itself. Because the real revenue doesn't come from the printer. It comes from what the printer requires to function: ink, toner, consumables. This model is not unique. It mirrors a structure often referred to as the razor and blades model, where the base product is sold cheaply, and ongoing purchases generate profit. In the case of printers, those ongoing purchases are not optional. They are mandatory. Once a consumer buys into a specific printer ecosystem, switching becomes costly. Cartridges are proprietary. Compatibility is restricted. And alternatives are often limited. The result is a controlled environment, where the manufacturer retains influence over how the product is used long after it is sold. To understand why printers fail the way they do, you have to understand what they are optimized for. Not maximum durability, not lifetime performance. They are optimized for a balance: performance, cost, and expected lifespan. Inside a printer, there are components that wear down predictably: rollers that feed paper, print heads that deposit ink, waste ink pads that absorb excess fluid. Each component has a finite life, measured not in years, but in cycles. Pages printed, movements performed, operations completed. From an engineering perspective, these limits are known. They are measurable, and they are often predictable. Given that limitation, the question becomes: how long should the product last? Long enough to satisfy the customer. Long enough to avoid warranty claims. But not so long that it disrupts the replacement cycle. That balance is where design decisions begin to shift. When printers fail, they rarely fail randomly. They fail in ways that are consistent, repeatable, and often similar across large numbers of devices. One of the most common failure mechanisms is the waste ink system. During cleaning cycles, printers flush ink through the system to maintain print quality. That ink has to go somewhere. It is absorbed into internal pads. Pads that are not designed to be replaced easily. Over time, those pads saturate. And when they reach a predefined threshold, the printer stops. Not because it physically cannot function, but because the system has determined it should not continue. Inside many printers, there is a counter. It tracks usage, cleaning cycles, estimated wear. When that counter reaches a limit, the device locks. This behavior is not hidden. It has been documented in service manuals, acknowledged in support channels, and experienced by users across different models. Modern printers are not purely mechanical devices. They are controlled systems. Firmware governs behavior, determines compatibility, manages functions, and software introduces a new layer of control. Cartridges are often equipped with chips. These chips communicate with the printer, verifying authenticity, tracking usage. If the chip reports an issue, even if ink remains, printing can stop. From a user perspective, this feels arbitrary. Ink appears to be present. The device is operational, but the system refuses to proceed. From a design perspective, it is consistent. The printer is not responding to visible conditions. It is responding to programmed thresholds. When a printer fails, repair is theoretically possible. Components can be replaced. Systems can be reset. Pads can be cleaned. But in practice, repair is rarely pursued because the cost structure discourages it. Labor is expensive. Parts may be difficult to access. Service documentation may be restricted. And when the total cost of repair approaches or exceeds the cost of a new printer, the decision becomes predictable. Replace. This is not an accident. It is the result of aligning product design with economic incentives. A device that is affordable to buy, costly to maintain, and difficult to repair naturally leads to a cycle of replacement. Ink is not a neutral component. It is a controlled resource. Manufacturers design cartridges to work within specific systems. Third-party alternatives exist, but compatibility is often restricted. Firmware updates can change behavior, blocking certain cartridges, altering performance. The printer becomes dependent on a supply chain controlled by the manufacturer. This dependency extends the life cycle of revenue beyond the initial sale and reinforces the incentive to maintain control over the system. Is this illegal? In most cases, no. Manufacturers are allowed to design products within regulatory boundaries, as long as safety standards are met, as long as disclosures are sufficient. Intent is difficult to prove, and design choices can be justified as quality control, user protection, system integrity. Where concerns arise is not in individual decisions, but in their combined effect. System where products fail predictably, repair is discouraged, and replacement is normalized, exists within legal boundaries, but raises broader questions. From the outside, the experience feels inconsistent. The printer works until it doesn't. Failures appear sudden, unexpected, but when examined across many users, patterns emerge. Similar error messages, similar timelines, similar outcomes. Over time, expectations adjust. Consumers begin to assume printers don't last. Ink is expensive. Replacement is easier. And once that expectation is established, the system stabilizes. From the manufacturer's standpoint, the system is logical. Margins on hardware are limited. Competition is intense. Pricing pressure is constant. Revenue must come from somewhere. Consumables provide consistency, predictability, and control. In exchange, durability may be constrained. Repairability may be reduced. Not because failure is the goal, but because optimization has shifted priorities. Printers are not uniquely flawed. They are examples of a broader pattern in modern consumer electronics. Products designed within systems that prioritize cost efficiency, revenue continuity, and controlled ecosystems. Within those systems, durability becomes one variable among many, not the defining one. The printer on your desk is not failing randomly. It is operating within a framework built on measurable limits, economic incentives, and design decisions made long before you pressed print. And once you understand that framework, you begin to recognize it elsewhere. In other devices, other systems, other products that work, until they don't. The question is no longer why your printer breaks. The question is, what exactly was it designed to do? If you want to understand what the products you rely on are actually built to do, not just what they promise, subscribe.